Okay, we are 20 seconds away. There's my template. So, yeah, let's get started. Oh, that is not good. Okay, great. Where will I find it now? Great. That was last moment. Well, this is the boring part probably, and you have the last question coming up first, which is not something that you wanted really. Okay, things are coming now. Okay. Zero index trigonums subarray is alternating if m is length greater than 1. S1 is equal to S0 plus 1. Zero index subarray looks like S0 S1 S0 S1. Okay. The return the maximum length of all alternating subarrays present in nums or -1 if no such subarray exists. Interesting and should be straightforward. Yeah. So it's a continuous thing. So int val equals 0, int max equals 0, int n equals to nums.length, and I'll just get started for well, okay, wait, m is greater than 1 is m is greater than 1. Okay, expectation is very clearly laid. So val can be taken as equal to 1, and then for I equals to 0, I less than or equal to 1, int I equals to 1, I less than n, I plus plus. If it continues that nums I is equal to this is interesting. Let's keep a flag to say that initially it was 0. Numsci equals to numsci numsci equals to numsci -1 plus 1 and flag is equal to 0 or flag is equal to 1. These are the cases when you expect one greater now, and then you will basically say val plus plus and f is equal to 2, else if numsci is equal to something -1, sorry, that thing -1, then you expect it will be 0 or 2, and you write val plus plus f is equal to 1. After everything you have to say if I think max is -1. If the val is greater than 1, then max is equal to max comma val. I think something else is necessary. If none of these are satisfied, then val is equal to 1 and just carry on, f is equal to 0. This should do our job. Return max 100. Okay, we could have brute forced. Well, is it working? No, I'm afraid. Let me just copy it somewhere. Okay. Well, okay, something different. Not returning as a result, the web page is not displaying. Or did I motivate too many people in my previous one? Mm-hmm. Anyway, we can read the questions. You're given zero indexed integer added nums representing initial positions of some marbles. Okay, I think something has come there. Yeah. Okay. Why is it entering that state? Okay. Marbles given zero indexed representing initial positions to zero indexed integer address move from and move to. Throughout move from dot length steps, you need to change the positions of the marbles. On the ith step, you will move all marbles at position move from I to position move to I. Okay. Initial positions are all given. Okay. Return the sorted list of occupied positions. Only the positions, which should not be difficult. Okay. Let us see this. Should I click on this or should I just click on submit? Okay. So we will have a list of these positions, initial positions. Then we can sort of map them, and as a result of that, remove them. I think some game of hash sets. Nums dot length, move from dot length, move to dot length. Okay. And what is the number of? Okay, 10 to the power 5 times it changes. Okay, so it can't be the brute force thing. It can't be the brute force thing. 1, 6, 7, 8 move from, and 1 will move to 2, and then 7 will move to 9, 2 will move to 5. Can it be? It can be, right? Initially marbles at positions 1, 6, 7, 8. Okay, 1, 1, 3, 3. Let's see this one. 1, 2, 2. So 1 I'll remove and 2 I'll keep. 3 I'll also remove and 2 I'll keep. Correct. Well, I didn't participate in the contest for the first time, but okay, something happened. 2, 3, 4, 3, 4. It ran 2, 3, 4, 3, 4, which is fine. And the output is 3 and expected is 4. Val is 1 initially. So val is 1 initially, val plus plus. Let us see what happened. 2, 3, 4, 3, 4. 2 to 3 is it increased by 1, and then 3 to 4. Ah, that is interesting. That is interesting. That is interesting. So a bit, again, a bit of a mistake. For int I equals to 0, I less than n I plus plus. For int j equals to 1, j less than n j plus plus. Just keep this thing and say that, hey, if nums j minus is equal to nums I and j minus I modulus 2 is equal to 0, then do the max thing. Max equals to math.max max comma j minus I plus 1, else max equals to else if you have something like this. Nums j is equal to nums I plus 1, and this is equal to 1, and then again the same story. If they are not the case, then please break. Return max, this should be correct. Did it run? Run code status unknown error. Really? Expected 4, 2, 3. For each I am checking. For the next I also. Okay. I plus 1. Sorry. Is it running? Well, this is okay. It's not running because I didn't initialize n. Nums.length. Well. Output will be a list, it seems, in this question. So int n equals to nums.length. For int I equals to 0, I less than an I plus plus, and then we can use a hash set integer. Okay, if this looks correct and if submit button is working, let's put on submit. New hash set. Well, set and set. Well, we'll be adding set.add nums of I. Now, as I'll move forward, for int I equals 0, I less than move from, let's name it as m equals to move from dot length as an m I plus plus, and now what I'll do is I'll say take from basically set dot remove. I'm going one by one. So set dot remove move from I, and then set dot add move to, I think the sequence is correct, move to I, and return okay. int list, that's good. List integer L equals to new list, new array list. Okay, I don't know if there is an inbuilt function, so I'll go in this way. L.add y, and then I'll sort this, so it's collections.sort. So far as I remember, sort L, and then I'll return L. Submit failed. Please try again. Okay, I submitted. Let me move ahead. Let me run the code here. Have they written something like they have surrendered? Anyway, should work. Let us see. Partition string into minimum beautiful substrings. Did I? Please try again. Why is it failing? Well. Given a binary string, partition the string into anonymous substrings such that each substring is beautiful. A string is beautiful if it doesn't contain leading zeros. It is a binary representation of a number that is power of 5. Okay, that is a power of 5. 5, 1, 0, 1, and then power of 5, 25. What is the relation? 5 is 101. 25 will be 24 plus 1, which means 16 plus 8 plus 4 plus 2 plus 1. So 11001. When it is 125, should I do the effort of writing that? No, I think let's see. Return the minimum number of substrings in such partition if it is impossible to partition this string into beautiful substrings. Okay, okay. Sorry. Sorry. Return -1. There is some notification. Quite still. Hmm. 101 and 1. 1 itself. 1 itself is also a possibility. 11001. Okay. Yes. 111 correct, and this is -1. That is correct. There is one interesting thing. Okay, the length is 15. Length is 15. So it's kind of a backtracking thing, which it seems to be expected. So we can yeah, backtracking should be sort of straightforward. So minimum beautiful substrings and string, we can sort of take the substrings unhesitatingly. Am I the only one who is facing this? Let me look at the leaderboard. Yes, we'll discuss where is the leaderboard. Where is the leaderboard? Users accepted only 24. So definitely, yeah, people are unlucky a bit. Well, this is not the contest which you really find interesting, but whatever is in our hands, let us see. Okay, for int I equals to 0, I less than n, I plus plus. What is n? N is the length of the string, s dot length. So if sorry, int y equals to y, right? 2 to the power 15. What is 2 to the power 15? 2 to the power 30 up to their int comes. So 2 to the power 15, totally fine. If it starts with 0, that means we can straight away ignore that. So if n equals to 0, return true. Sorry, return, what do we have to return? Minimum number of substrings in such partition. Okay, so 0. If s dot substring, if s is if s dot caret 0 is equal to 0, then of course return minus infinity, something like that. I think -1. And now I equals to 0, I less than n, int y equals to 0, y equals to if y equals to y into 2 plus s dot caret I minus 0. So this gives me the number, and if let's see, int k equals to y, if while k is greater than 1, k divided by equals to 5. That way we will know that if k is equal to 1, then this is a correct possibility. So the value, sorry, the answer int age equal to int answer equals to integer dot max value. It will be answer equals to math dot min answer comma 1 plus minimum beautiful substrings s dot substring I comma sorry I plus 1 I think sorry it should be, yeah, I plus 1 it should be, from I plus 1 onwards. We'll send that, we'll collect that. There is a fun over here. Int x equals to, let's copy this, and if x is greater than equal to 0, then do this 1 plus x, otherwise not. Then you come out and you return answer, which should work fine. Answer equals to math.min, yeah, it should work fine. Now I don't know whether there is any use of clicking on this run and submit button, so let me click if something comes. Unknown error. Okay. I don't have a different simulator for this. I have to create one, but it's fine. I can sort of keep it and wait till it. Okay. Number of black blocks. So we are 22 minutes to the contest. Let's see if we can also finish this. Then if something doesn't pass out of, I'll explain the things and then we will call it a day. Maybe I'll take it up in a separate session whether the answer is really passed or not. Number of black blocks, two integers m and n. M cross n is a grid. You're also given 0 indexed to the integer matrix coordinates. Coordinate size equal to x comma y indicates that the cell with coordinates is marked black. Okay, so black ones are mentioned, which are not there, they are white. A block is defined as a 2 cross 2 submatrix of the grid. More formally, a block with cell x comma y as its top left corner, where contains the return 0 indexed integer array of size 5. So that is a number of blocks that contains exactly I black cells. Okay. Why? Okay, this is a medium level question. This is a medium level question. So, there's nothing much to do over here, I think. Just, why want a brute force surface? Let me think through it. M and N, what is M cross N? That is the fun. M cross N will be very large, so we can't go that way. But the total number of coordinates is 10 to the power 4. So our cell can be, there are 4 possibilities. I can see 4 into 10 to the power 4 starting cells that we may be concerned with. For the remaining ones, it should be, let's think this way, that there is, a black which is mentioned. So I'm interested in this cell, in this cell, in this one, in this one, in this one, of course this one too, uh, in this one, then this one, then this one. So every coordinate sort of gives me 9 coordinates I'm interested in. 9 into 10 to the power 4 means 10 to the power 5, which is around 10 to the power 5, which is not a big deal. We will start with those coordinates. For those coordinates only something is possible. Wait. Why are these involved? As starting coordinates, this one, this one, this one, and this one will involve it, not this. From the rest of the positions, if it starts, this one won't matter. So for these only we are going to count it. So we are not going to count it for 0, we are going to count it for 1, 2, 3, and 4. Yeah, this should be straightforward. So let's get started. Long what? Long. Contains exactly black cells. Okay, long answer equals to a new long 5. And now long total is equal to 1L into n into m. And then I'll get started. I equals to 0, I less than I plus plus. No, less than m, I think, because that's the, sorry, number of coordinates. Int len equals to coordinates dot length. Let's take a hash set. Pair. Let's take two different. That is not possible. Pair, yes. Let us take a pair. What does it say? Okay. Class pair. Don't need this. Well, int AB, and that's it. Int just need a pair. Hash set pair. I want unique, right? That's the reason of using hash set. So that's a different way. Let's choose a different way. Long. Hash set long set equals to new hash set. Problem with pair with B, it would mark by the address, and even if the values are same, it won't take them as same address. So I'm shifting to a different strategy. Set dot add. Let me find out int. What are the coordinates? Int x equals to coordinates I0. Sorry. This is y, and then this is 1. Set dot add x into. I think this can be kept as long. Yeah, should be kept as long. X into m plus y. I think m is the number of columns. Y is the column number. So this should work. X into m plus y. Set dot add. I think now, what are the ones we discussed? If this one, then x minus 1. So there are 4 such lines which are relevant. -1, x minus 1, y minus 1, x plus y minus 1. Once this is done, now we can come down and we can say these are in the computation. Something is remaining. If x minus y is greater than equal to 0, and y minus 1 is greater than equal to 0, if y minus 1 is greater than equal to 0. So that means these are valid. I clicked on save button. It's a habit. Okay, now I'll come down and I'll do that thing. Okay, take these as a starting points for int whatever d in your set. Int x equals to long x int x. What are blocks, right? Yeah, so fine. X equals to int d divided by m, and y equals to d modulus m. Now that I'm done with this, I can move ahead and store in the set. No, I'll basically check all of them. Int c equals to 0. Sorry, it should be 1 because no, let's keep it 0. If coordinates x y is equal to 1, right? Black oh, if it is there in the set, I think that's what we need to see. If set dot contains contains x into m plus y, then c plus plus. If I think we don't need to check the limit because no, I think it's better to check the limit. If x plus 1 into m plus y is contained by the set, again bad strategy. If x plus 1 is less than n and set dot contains x plus 1 into m plus y, then c plus plus. And I'll again reiterate the same thing. If y plus 1 is less than m, okay, I forgot or missed the brackets. There you go. X plus y plus 1, okay, so x plus y plus 1, then c plus plus. M is long. Oh, m is not long, then I think this should be long. This has to be long. Let it be x into m plus y plus 1 and y plus 1 less than m, which means that it will be y plus 1, c plus plus. Now that we have got away with this, we can say answer of wait, which blocks are we counting? 1, 2, 3, 4. Okay, we're not looking at all the blocks. Okay, so if x is equal to n minus 1, or y is equal to m minus 1, then continue. This is because we will check only the starting positions which lie up to the penultimate row and up to the penultimate column. The last row and last column won't have the starting positions. So now I'll say answer of C. Answer of C is going to get added, and total is not going to be n into m. It will be 1l into n minus 1 into m minus 1. And there you go. You just have to return. No. Answer of 0 is going to be equal to total minus answer of 1 minus answer of 2. And now you know why I wrote the total. Answer of 3 minus answer of 4. And now it should be returning the answer. Well, whether these buttons will work or not, we don't know. I'll click on submit starting here. Okay, something is working now. Let's see one by one. So now things are queued, it seems. Okay, accepted. Now the second one. Nice. Third, I hope the acceptance algorithm has not got screwed that everything it is accepting, but anyway. Okay. 1 1 1. Well, why is my output 1? 1 1 1 is 7, which doesn't satisfy. The answer is integer.max value. Wait. How did 1 come? Okay, last one. Let's submit. Let's see. Okay, run code should also work. Okay, these things are there. X into, yeah, there it is correct. This is also correct. This one is not correct. Okay, cool. The bracket is missing, by the way. So what is a compiler? mset. Where is mset? Set. And now things should be fine. D colon set int. Okay, it's long, right? It's long D set. Okay. My answer is 31000, and my input was 3. Which one did I do? 3 31000, which is correct. And now I'll use the example test cases and run. Again and again this should not happen. Okay. 31000, 4 times 1 0. No, there's something problematic. 022 is 1. Why is this 2? This has 2 black cells, this has 2 black cells. This has 1 black cell, this has 1 black cell. Right. What did I return? How did I get 4? M is a number of columns, right? Or opposite? Oh, M cross N grid. That is bad. That is seriously bad. Let me just swap N and N is equal to N. How did I do that? N plus M minus M equal to N. Uh, let's see. Should not be changing, but anyway, my answer is still 0111. Uh, Let me print it now. System.println print d or println. Let's see d. In this case, we'll have 1, 2, 3, 4. Is this really 1, 2, 3, 4? Is this really 1, 2, 3, 4? Well, let us see. Yeah, 1, 2, 3. It should be 5, right? Sorry, 0, 1, 2. It should be 0. 1, 2, 3, 0, 1, 2. Last column won't be inverse, so 0, 1. Last column shouldn't be involved. We are going to continue that, which is fine. So then before continuing, 0, 1, 2, 3, 4, 5. Let me print this later on after this. D plus space plus X plus space plus Y. Okay. Okay. 0, 0, 0. Where is it starting for ours? Let us do only this. Yeah, let me remove this run code. 0, 0, 0, which is correct. 0, 0, 0, 1, 1, 0, 1, 1. Yeah, 1, 0, 1, 1 is also correct. But what is the D value? Am I decreasing M somewhere? M is equal to 3, right? M is equal to 3. Okay. So if up to here 0, 1, yeah, 1, 0, 1, 1 and 3 and 4, correct. Now what is happening? For 0, 0, I look for 0, 0, 0, 1, 1, 0, 1, 1. So it should give me 4. Yeah. Okay, 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 okay. That is my mistake. That will be a different set. Set 1. That's my mistake. Set 1 dot add x into m plus y. Yeah. And I should check in set 1 and not set. Set 1, set 2, set 1, set 1, set 1. 0, 2 to 0, 0, that's it. So both the sets are different. The first set basically gives me that what are the potential starting positions which will have at least one cell in that block. And then the second set tells me that what are the positions where we have black cell, or what are the positions of the black cell. So I'll remove this debugging line. I'll include all the examples once again, run it. Yeah, which is fine. So now let me submit it because I think there are no other cases. Long, I hope I'm not missing long. It's fine. Yeah, sleek correct. So let's submit. Okay, accepted. Now this one, what have I done here? This is a known case, 111. So shouldn't happen like this. But there is some mistake over here. If answer is equal to integer dot max value, then of course we have to return -1. Return -1. This may be the issue. So return example test cases. Let me run it. 2 1 minus 1. 2 1. Okay, 1 is being returned. That is strange. So let's see, 1 into 2 plus 1. First time when it comes, basically it will have 0. So 0 into 2 plus 1 is 1. K is 1, so I'll move inside. I'll say x is greater than equal to 0. That means answer comma 1 plus x. Next time when I go n equal to 0, no. Is it 0? No. Y equal to 0, integer dot max. Okay, let me print. This is a recursive thing, so let me print ln s plus space plus answer. So for triple one, I think we are over here. For 1 it is 1, which is correct. For 1 1 it is 2. Oh, wait, for triple one it is 1. For 1 1 it is 2. Yes. So when we return it, x greater than equal to 0 is this. So s plus s dot substring plus x plus s plus answer. I'm just popping down everything I have in my mind. Did I click on submit? I hope no. Oh, I clicked on submit, is it? I should have clicked on run code. Anyway, I have not yet figured out where is the leaderboard. That is weird. Ranking. Ah, okay, I need to refresh this, it seems. First of all, return there and make it work. Okay, 0 1 1 minus 1. Okay, here we start. 0 1 1. Where is this space coming from? Okay, substring is empty. Empty substring. That means I'm leaving 0 for later than 1. Yeah, for 1 it is 1, right? For yes, at the last one, that's what I'm doing. Then 1 1, so it is 11. I'm separating the 1 and then thereby I'm getting 2. Then I'm getting this 3 is 1 1 1. Why is this entering the loop there? Why is this entering? This should be 7 minus 0. So y equals to y into 2 plus, what is y? So let me print k over here. How could this dare to enter if yeah 1 k. Oh, sorry, that is my mistake. So what I basically did is I'm evaluating whether this is divisible by 5 or not. The problem is I should do it as long as it is greater than equal to 5. While it is greater than equal to 5, keep on doing this. Then don't do this. But while k is greater than equal to 5 and k modulus 5 is equal to 0, it must be divisible by 5. Now it should be correct. That was bad. Actually, the case where we only check by 2, here it's 5, but when we check by 2, it's so simpler. We don't have to worry about these cases because many cases don't come. In case of 5 or other numbers, we have to be much more careful. Okay. 2, 3 minus 1, is it so? Yeah, 2, 3 minus 1. Remove all this rubbish now. Okay, I'm not in the mood to really try out my own cases. 2, 3 minus 1 makes me happy, so I'll submit it. Yeah, there it is. So now I'll maybe try to find out the leaderboard. I know many people have just left it. Well. 847 total accepted. So there is not much to say about this contest. Users accepted 134. Fine, not bad. So I should be somewhere around 130, 140. Where can I get the leaderboard? My playground, is it? Oh no, it's not. Now you might find yourself senior to me here, but I don't have a way to ask you. Press. I think we should be able to find it here. Yeah, there it is. Ranking. Rankings may not be updated. 106. Well, this is my second Leetcode contest. So before closing this, more or less we are done. So before closing this, let's quickly brush up whatever we did. The first question is longest alternating subarray, where it basically says we have to find out the maximum length of all alternating subarrays present. Now I've forgotten the question. Okay, I think out of all the alternating subarrays, we have to find which one has the maximum length and what is the maximum length basically. So I did something before. What I did before was I was thinking in terms of a 2 pointers thing, but the problem over there was I was extending it. I started at a certain position, I extended it. So the problem that I faced is let's take this as the example. So I took this 2 and then I extended to 3, which was correct. And then I saw that 4 is not fine and then discontinued it. I said that, hey, now start from 3. Now start from 4. And starting from 4 was the wrong step. I basically said that, okay, up to 3, whatever was continuing, I'm unable to continue that. So now start afresh from 4. I think I did something like this. That was the mistake. Instead of that, basically, what I needed to do is, I hope that that was clear. So 2, 3, 4 is where the violation happened. And what I basically said is, okay, now just remember this 4 and continue from here. What I forgot is that previous 3 can also help, can also get involved in this process. That could have been a clear fix. That could have been an easy fix. But what I rather did is I just saw that there's a brute force thing, much more brutal than I expected. So I just went through a much more brute force process, that is, take every starting position and every ending position and see if it works. And I use this break to say if it doesn't work for a certain change, just break it over there. Yeah, so in n squared time, they sort of give me the answer. And now relocate marbles. What did I do? I said that this basically told me that okay, in some positions there are some marbles. Now every step is telling me empty that bucket into this bucket. And in every step there is only one bucket shift. There is only one bucket shift, that from a certain I we are going to move to a certain j. We don't have a combination that okay, in a certain second or in a certain step we will have k such transitions or such transitions. If that would have happened, I would have to think more. But in this case, yeah, this was simple. In one step, you just have to basically say, okay, that bucket is gone, this bucket has come. And in the next step, okay, that bucket has gone, this bucket has come. That's it. One interesting thing is, I didn't check whether in move from I there is anything or not. I didn't check whether in move from I there is anything or not. So ideally there should have been a wrong answer verdict. There should have been some mistake. This is a corner case, I think. Through you need to change the position and you move all marbles. Yeah, we need to check whether in move from I there is any marble or not. I think in this solution that step is missing. We should add it only when we are removing something. So previously we are adding whatever are the positions where marbles are contained. So we should remove it. I mean, we should basically add this only when we are removing this. Had it been a better, I mean, a more competitive platform, I think, or maybe if the authors would have been a bit more, more correct or careful about it, I think they have missed the case. They would have, it should have given a runtime error in my case. It would have said that there is nothing to remove because it hasn't been entered over here. So it should have directly given me a wrong answer there, or a runtime error there. And even if I avoid the runtime error by saying okay, if it is there then remove, otherwise don't remove, but I keep the rest of the code the same, then also I would have stepped into a wrong answer, because it would have told me that hey, you removed something but you did not add it, something like that, right? It would have basically said when I would have added it, at the end it would be counted, but I'm not supposed to count it because there is nothing over there, so I'm not supposed to count it. List L, that is fine. L dot add, yeah, more or less that is fine. I'm sorting it. Collections.sort works in nlog n time, so pretty straightforward. Partition the string into minimum beautiful substrings. Power of 5. So the constraints is the key. The constraints basically tells us that hey, do some recursion and show me that you know recursion, or rather it's backtracking. It could have been done probably in the form of a DP as well, I believe. DP would have been possible, but the constraints didn't really encourage me to think of that. It would have been a 1D DP only, but it didn't just encourage me to do that. So fine. What I did is I basically said that okay, for S, find out every prefix which is valid. This basically tells me whether it's valid or not. K equals to 1 means it is valid. Why? Because I'm basically saying that okay, keep on dividing by 5 as long as you can, and then finally see if you are reaching 1 or not. That means you have kept on dividing by 5. Each was a multiple of 5, so it's 5 to the power something. So maybe let's also read the question another time. Given the binary string S, partition the string into one or more substrings such that each substring is beautiful. A string is beautiful if it doesn't contain leading zeros. It's a binary representation of a number that is a power of 5. So I need to check that there is no leading zero in the substrings that I'm taking, and it can be I can divide the string into these two substrings, or I can divide into these two substrings. One substring decreasing may improve my answer. Basically, if I choose this as the first substring, maybe I'll get two more substrings. But if I take a longer one, a longer substring, maybe I'll get two substrings to fill up the string. So that's the strategy basically. Yeah. So what I did is I basically found out whether my current prefix, which is the substring from 0 to I, is a beautiful substring or not. If yes, then find out after that if you whether you can divide into beautiful substrings. If it is -1, if it is returning -1, then straight away return, then straight away ignore. Otherwise, you will do something like this, that okay, this is one substring which we have already created over here. This is one substring. The remaining is X. That is a number of substrings which we can sort of, that is the answer for the remaining part. You know how recursion works. We are using a recursive approach that, hey, I'm not going to worry about how this thing is going to be evaluated. So I'm sending the problem to the next guy that, hey, solve it for me. And then I will add myself to it and fetch the answer. And then I'll do it for every prefix. Look over here. I basically tells me the number of prefixes. So if you go back for every starting position of the string, I'm at the maximum I'm evaluating 15 ending positions. 15 times this is going to run, and every time I'll call something and I'll evaluate something. This brings it to 2 to the power 15, right? Or is it more? Well, the question basically makes it clear that it is a backtracking thing, and there is another fun to it. If I have to sort of evaluate the time complexity, I need to do some mathematics. The mathematics will be that can we have a number? Can we have a binary string xxx, something like this, whose this prefix is also a binary string? For example, let's say some 1 0 something dot dot dot, and there is something like 0 1. If this is a binary string, can this be a binary string? If this is a binary string which is a multiple of 5, a power of 5, will its previous prefix be a power of 5? No, it won't be. It won't be because if the previous one would have been a power of 5, let's say the previous one would have been a power of 5. Simply let's say it's 5 to the power something, 5 to the power x. Then when we basically put a 1 in front of it, it will be 5 to the power x into 2 plus 1. This basically tells us that it will be in the decimal representation, we will have 1 as the last digit, because into 2 plus 1, this is in decimal, 5 to the power 2 plus 1, 5 to the power x into 2 plus 1. So it's some multiple of 10 plus 1, which basically means that what does it mean? It basically means that my assumption was wrong. This definitely was not a power of 5. Now, if it were 1 also, then also if this guy, the previous one, if it were 1 also, then also my inference would have been the same thing. That hey, if that previous one, if that prefix would have been a power of 5, then after adding a 1, it cannot be a power of 5. Similarly, after adding 0, it definitely won't be a power of 5. So that is one assurance. Now, if I do another thing, into 2, then also it is not matching. But if I say that okay, I'll be adding 2 to it, basically up to here there is something, up to this x, let's say, whatever prefix up to x, that is divisible by, or up to y, that is divisible, or that is a power of 5. After that, if you put 1 1, will it be a power of 5? It basically means that okay, you are multiplying by 4 and then you're adding 3. So no, it won't be. And so on. You can understand that if you add 0 1, it's the same thing. So only when you add 1 0 1 in front of it, it is possible. So this actually plays a role in determining how many branches we will have. I sort of understood, I sort of took a gamble over there from this question that this will always work, but actually this is working over here. If you think more critically, maybe at each starting position there are 15 ending positions, or let's say 7 ending positions on average. So just taking the average for simplicity, it will be 7 children for each of them, which is 7 to the power 15, right? 7, and then that will also have 7 and so on. 7 to the power 15 is a large thing. So definitely it wouldn't pass. So this mathematics is coming along to make it pass. And it is not essential to do this mathematics because there are 99% cases where it is predictable, and that's why we avoid that mathematics. But actually, yeah, the mathematics comes in somewhere or the other. So yeah, not a bad question. A practice on backtracking for some of you. Okay, and then number of black blocks. This basically m cross n grid. I was not prepared for m cross n. I was prepared for n cross m. So I had to do a swapping here. This is a one line swapping, which sometimes yeah, I just end up using. Somewhere in my school time I got familiarized with this, and yeah. The question is simple. It basically says that consider 2 cross 2 blocks. 2 cross 2 blocks means this is a 2 cross 2 blocks. I hope you can see my cursor. This is a 2 cross 2 block. This is another 2 cross 2 block. This is another 2 cross 2 block. This is another 2 cross 2 block. Consider all the 2 cross 2 blocks and tell me how many 2 cross 2 blocks have 0 black cells, how many have 1 black cell, how many have 2 black cells, how many have 3 black cells, and how many have 4 black cells. Now, m cross n, that is going to be huge because m and n both are going to 10 to the power 5. So automatically I know 10 to the power 5 cross 10 to the power 5, I can't create such a matrix. I can't deal with all those cells because 10 to the power 10 is beyond the number of operations that I can perform. So automatically I get the idea, okay, the trick is in this coordinates thing, the number of coordinates, which is the number of black coordinates, is only up to 10 to the power 4, and this is where I have to optimize. This is where I have to optimize. So what I basically do is, based on these coordinates, I'll find out what are the potential starting positions which will have some involvement of black. So what I figured out is I created this diagram to say, okay, if this is a black cell, this is a black cell, then this itself is a starting position. Its top guy will also be a starting position because we'll be interested in, yeah, this part, these 4 will come for this particular starting position, and so the black cell will be involved. This is another valid starting position, this is another valid starting position. For these 4 starting positions, this particular black cell is involved. So I went through all the black cells and I brought in all the potential starting positions in this set. This is where I did it. And I created a different set to store my black cells, and I stored that in set 1. How am I storing it? I'm not storing it as pair because in Java it may be different from C++, but in Java it would remember it by the address. So if I create 2 pair objects, let's say I create a pair object 2, 3, and then again later on I create another pair object 2, 3, they will have different addresses. So when I add them in the hash set will treat them as 2 different objects, and so that will be some unnecessary computation. Since I'm fetching from that set, it will go wrong over there. I'll fetch the same pair multiple times, which is wrong. So cool. We will have 2, 3, all these things. So now what did I do? Now I came to each of those potential starting positions, not just potential, they are in fact exact starting positions. I came to them and I said, hey, give me your x coordinate and y coordinate. I used a trick. I didn't use a pair, so I used a trick of this sort: x into m plus y. This is basically x into number of columns plus y. Why this? Because I know that y is less than m. Y is less than m. I basically swapped n and m, again I'm mentioning. So that's why I know that y is less than m. And because y is less than m, I could directly use it. I know that when I do modulus of this value by m with respect to m, I'll be getting y. And when I do division by m, I'll be getting x. That's it. Set 1, similar strategy. So I'm able to store them as a single value. I'm able to get the 2 values separately whenever I want. That is the reason I use this. Then I'm coming down, x equals to n minus 1, m minus 1, and okay, if they're in the last row, last column, then continue. This logic could be incorporated here as well, but your choice. And then something like this, set one dot contains, yeah. So I'm checking whether yeah, taking x and y as a starting position in that block, how many cells are black. So I'm checking the current cell, I'm checking the right cell, I'm checking the bottom cell, sorry, this is the bottom cell, this is the right cell, and this is the right bottom cell. In this way I'm checking all the four cells associated with the starting position, and for that particular value which is the number of cells which are giving me the desired which are black, for that particular count I am adding the counter. For this count I have found one starting position. Finally, what am I doing? Total is the number of starting positions. Total is the total number of starting positions, which is n into 1 into m minus n minus 1 into m minus 1, and I am subtracting all the other things from there, because all these other things I am calculating already over here. Then I'm returning. Remember, this answer 0 I could not calculate over here. Why? Because the number of positions in the total grid was beyond my control. So yeah, that's it. So this was a bit better than the previous one. Let me know if you have any doubts, etc. And I'm planning to shift to other platforms like AdCoder, Codeforces. Let's see if things play out. Today I was a bit in a better mood or form, whatever you say. Anyway, and there was no hard question as well, so fine. Let me see this once again. I think I screwed them up in the test cases only, which is why I lost. We can't say anything about these rankings because the contest was totally screwed up. Okay, whatever. Take care, keep coding.